Welcome to Cupertino Aviation. In this video, we'll briefly look at lift and basic aerodynamics. Before we can understand the components of an aircraft, it is important to have a basic understanding of aerodynamics, and how lift is created. There are four forces that act on an aircraft in flight. These are thrust, lift, weight, and drag. Thrust is the forward force that is created by the engine driving the propeller. As you might expect, thrust overcomes drag. Drag is a rearward force that is caused by the disruption of airflow around the wing, fuselage, and any other objects in the airstream. Generally speaking, thrust acts parallel to the longitudinal axis of the airplane. Drag opposes thrust and acts parallel to the relative wind. Weight is just as it seems. It is the total load of the aircraft, including the aircraft itself and everything in it. The force of gravity causes the weight of the aircraft to pull it downward. Weight opposes lift and acts vertically downward through the aircraft's center of gravity, sometimes referred to as CG. Lift is produced by the wing and opposes weight. It acts perpendicular to the path of the aircraft through the center of lift of the wing. The center of lift is sometimes abbreviated CL, although the abbreviation is usually not spoken. Now that you understand the four forces acting on an aircraft, we can talk about how an aircraft moves in 3 dimensions. An aircraft is controlled by causing it to move around one of 3 axes. The longitudinal axis, also called the roll axis, goes through the aircraft from the nose to the tail. An aircraft rolls around the longitudinal axis. The lateral axis, also called the pitch axis, goes through the wings of the aircraft. An aircraft pitches up and down around the lateral axis. The vertical axis, also called the yaw axis, goes through the aircraft vertically. All 3 of these axes, the longitudinal axis, the lateral axis, and the vertical axis, intersect at the center of gravity of the aircraft. Every control movement a pilot makes causes the aircraft to move around one or more of the 3 axes. We've mentioned the center of gravity, or CG, several times. One way to think of the center of gravity is that it is the point where, if we could suspend the aircraft from a rope tied to that point, the aircraft would be perfectly level and balanced. The position of the center of gravity is important because it affects the stability of the aircraft when it is in flight. The further aft the CG is, the more the aircraft becomes dynamically unstable, but also flies more efficiently. It is important for aircraft designers to get the CG correct and to consider things like the position of fuel tanks. A poorly designed aircraft could become excessively unstable if the CG moves too far as fuel is burned. It is also important for the pilot to understand how loading of the aircraft and installation of new equipment can affect the center of gravity. Aerodynamics is much more complex and nuanced than what we've just explained here, but it is enough to get started. Other videos will explore these concepts in more detail.